Welcome back to The Explainer, where we take complex systems and break them down into clear, visual takeaways. Okay, let's dive right into this. If you've ever looked inside a modern warehouse, the automation is incredibly easy to spot, right? Conveyors are humming, shuttles are darting between racks, and robots arrive at workstations with this almost theatrical precision. I mean, it literally looks like magic. But as you'll see, that magic actually relies on an invisible intelligence working behind the scenes, just to make sure the machinery doesn't get in its own way and cause absolute chaos. So let's figure out what this invisible brain actually is, the warehouse control system. Here is our roadmap for today. We're going to start with intention versus reality, then move into the warehouse software hierarchy, look inside the WCS cycle, see how it's coordinating the moving parts, discuss the benefits and hidden limitations, and finally, we'll wrap up with implementing WCS successfully. All right, let's kick things off with Section 1, Intention versus Reality, the chaos of uncoordinated speed. You know, warehouse automation produces just incredible speed. But speed without central coordination, that essentially just creates faster traffic jams on your facility floor. I absolutely love this quote from our sources because it perfectly captures the dynamic. The WMS writes the intention. The WCS negotiates with reality. See, your higher-level software, like a warehouse management system, requests that an item be picked. That's the intention. But the warehouse control system, it has to deal with the messy reality of what is physically happening in that exact millisecond. We're talking about a full buffer, a delayed workstation, or a route that looked perfectly clear just 3 seconds ago but is now completely blocked. So the crucial point is right here. A WCS coordinates physical execution. It's not just a static diagram or a database. Actually, scratch that. It's more like a living, breathing, real-time decision layer. It gets a request, it checks the current physical operating conditions, and then it selects the best possible route. When circumstances change, and let's be honest, in a warehouse they literally always do, the WCS adjusts instantly. Moving right along to Section 2, the warehouse software hierarchy, from business to floor. A major point of confusion for a lot of people is how acronyms like ERP, WMS, WES, and WCS actually work together. Well, the secret is they're all looking at the exact same facility, just from completely different distances. And this brilliantly illustrates that zoom level tightening from top to bottom. The ERP looks at the big picture, which customer demand needs fulfilling. Below that, the WMS zooms in on inventory and decides a specific tote of stock needs to be picked. Then, your warehouse execution system, or WES, decides exactly when that task should enter the operation. And finally, at the very bottom, our warehouse control system makes the hyper-local decision, which physical route should this tote take right now to get there? Think of it kind of like this. Higher-level planning software operates like a strict railway timetable. It expects things to leave at a certain time and arrive at a certain time on a completely fixed track. But material flow control for a WCS, that is much more like navigating busy city streets. The destination stays the same, for sure, but the best route shifts constantly to avoid congestion. A WCS has to navigate blocked buffers, slowed workstations, and unpredictable traffic jams in real time. It might hold a tote here or redirect a carton there, all just to keep the whole city grid moving. Okay, let's get into Section 3, inside the WCS cycle, ground-level execution. Let's move to and see how this builds. This right here is the fast, repeating mechanical heartbeat of a WCS, and it operates in a strict 5-step cycle. First, it receives a movement request. Second, it evaluates if the equipment is actually ready to go. Third, it directs the route and sends the instructions down to the machinery. Fourth, it observes the progress using physical sensors. And fifth, it adjusts, either confirming completion back to the upper systems or flagging an exception if something went off the rails. This loop is exactly where digital data becomes physical movement, and that movement instantly creates brand new data, which brings us to Section 4, coordinating the moving parts, speaking to the machines. So what exactly is the WCS talking to during that crazy fast cycle? Well, it connects a massive array of hardware. We're talking conveyor zones, giant automated storage cranes, and entire fleets of mobile robots. And it does this to prevent them from acting like completely unaware islands that just blindly bump into each other. Now, the immediate physical actions, like starting a specific motor or opening a single gate, those are still handled by programmable logic controllers, or PLCs. But the WCS, that is the master conductor orchestrating all those PLCs and robotic fleets so they actually work together as one unified system. All right, Section 5, benefits and hidden limitations, the stakes of integration. We're transitioning now from what a WCS mechanically does to what happens when it works perfectly.
And the ultimate goal here isn't just making machines run at top speed. It's really about reducing operational friction. A WCS makes sure that your busiest machine isn't drowning in work while another resource sits nearby with absolutely nothing to do. Saving a few trivial seconds on a single routing decision might not seem like a big deal, but when you multiply that by tens of thousands of daily movements, it completely transforms your throughput.
But I've got to pose a critical question to you, one that exposes the hidden, really high-stakes pitfalls of system integration. What happens when the physical movement succeeds, but the digital confirmation just fails? Imagine a carton arriving perfectly at its destination, but the "I'm here" message back to the WMS gets lost in a network. Suddenly, your physical world and your digital world are completely out of sync.
And that right there reveals the true limitation of a WCS: integration complexity. The hardest part of warehouse automation isn't actually controlling the machinery. It's deciding the precise integration rules between your software layers. Like, who actually owns the destination? Is it the WMS or the WCS? A warehouse control system is a brilliant coordinator, absolutely, but it simply cannot make an illogical, poorly integrated process sensible. Which leads us right into our final stretch, Section 6. Implementing WCS successfully. Best practices and mistakes. So how do we ensure a multi-million-dollar automation project doesn't quietly go wrong, just one bad assumption at a time? Now, what's really interesting about this slide is that very first point. Watching a highly polished software demo does not mean the system is going to automatically understand the awkward corners, the seasonal surges, and the mixed priorities of your actual warehouse. You have to analyze real floor processes. You also need to meticulously document integration rules so every decision has a clear owner. You've got to proactively maintain equipment based on minor alarms, train your staff on the underlying logic, not just how to push a button to magically clear a screen, and crucially, design the whole shebang for future layouts and new robotic vendors. I want to leave you with this final provocative thought to wrap up our explainer today. A great warehouse control system gives a facility something that machinery alone simply cannot provide: shared awareness. True execution keeps the flow moving by sensing operational pressure and adjusting in real time, well before those bottlenecks explode into total chaos. So ask yourself, does your automated facility have true shared awareness, or is it just incredibly fast machinery waiting for disorder to become obvious? Thank you so much for joining me for this explainer, and as always, keep learning.